My name is Aishwarya. So welcome to Neatment. Today let's do the types of processes, which is actually very easy. So let's start. First is isobaric. Second is isothermal. Third is isochloric. Fourth is adiabatic. Okay, if you see the similarities in these four processes, that any one state variable will be constant. For example, isobaric, pressure is constant. For isothermal, temperature is constant. For isochloric, volume is constant. For adiabatic, there is no heat exchange. That means delta Q equals to 0. Okay, so you should be very versed with this one. So isobaric pressure is constant, isothermal temperature is constant, isochloric volume is constant, adiabatic delta Q is 0. Also, because this process, sometimes a graph will be given, you should be able to identify which process is given in that graph. Okay. Let's start with isobaric. Pressure is constant. According to ideal gas, PV equals to nRT. Now pressure is constant, so that means V is directly proportional to T, because N and R we are taking as constant. Okay, it will be mostly N will be constant. If N is not constant, they will mention in the question. But V is directly proportional to T, that is V1 by T1 equals to V2 by T2. This graph is a straight line because V is directly proportional to T. It's a straight line graph. Okay. Now, according to first law of thermodynamics, delta Q equals to delta U plus delta W. Now, delta W equals to P delta V. See, PV equals to nRT, right? nRT. Now, P into delta V is nR root T. This is first equation. Second one, delta U equals to nCV root T. Right? Now, this CV you can also written as R by gamma minus 1. Delta U equals to nR root T gamma minus 1. Now, this is second equation. Okay? Now, delta Q equals to delta U plus delta W. Delta Q equals to, write the equations, nR root T gamma minus 1 plus nR root T. Now take nR root T up. nR delta T comes out 1 by gamma minus 1 plus 1. So nR delta T 1 plus gamma minus 1, gamma minus 1. This 1 get cancelled. Delta Q equals to nR delta T gamma minus 1. This gamma, so this n root T, this 2 is n root T Cp, because gamma by gamma minus 1 into R is Cp. What is Cv? Cv is R by gamma minus 1. Okay. Now, so we got the final equation, delta Q equals to nCp root T. Okay. So this is the heat energy, this is the internal energy, this is the work done formula. Okay. We know isothermal T is constant. So according to first law of thermodynamics, delta Q equals to delta U plus delta W. Now delta U equals to nCV root T. Now this one delta T is constant. constant, that is 0. So delta U equals to 0 and delta Q equals to delta W. We know delta W equals to P delta V. Now you also can write it as V1, V2, P dV. Okay, see delta V is also dV only. So PV equals to nRT. Now instead of P you can write it as nRT root by V. V1, V2, nRT V dV. Okay, now which is constant in this? N is constant, R is constant and T is constant. So we're going to write it outside. dV by V. Okay, so we know one formula, 1 by x dx equals to, right? So W equals to, W can also write it as delta Q, but N R T V2 by V1, or you can also write it as 2.303 nRT log V2 by V1, or also there's one more formula, 2.303 nRT log P1 by P2. Okay, so this is the important formula, and this one, this is for isothermal where T is constant. Okay, next is isochloric where volume is constant. PV equals to nRT if V is constant. P is directly proportional to temperature, that is P1, T1 equals to P2, T2, right? That means if it is directly proportional, the graph will be a straight line. Okay, so this is important relation. Okay, now let's go to first of thermodynamics. This is delta Q equals to delta U plus delta W. Here we know volume is constant. That means the work done equals to P delta V. Now volume is constant, so I'm going to take delta V as 0. So the work done will be 0. Delta Q equals to delta U, right? Now delta U equals to NCV root T. We know CD is R by gamma minus 1. N R. We know PV equals to nRT. Now we're going to take it as PV. P final minus V final minus equals P initial, V initial by gamma minus 1. So this is the formula. This is the formula for delta Q equals to delta U. The work done will be 0 because in isochloric the volume is constant. Volume is constant, V equals to 0. Then obviously work done will be 0. That's it. That's the main thing. This is a very easy formula. Isothermal we have seen, isochloric we have seen, and isobaric we have also seen. The last one left is adiabatic. adiabatic. Adiabatic is where there is no heat exchange is taking place. That is delta Q equals to 0. Now, we will take the first law, delta Q equals to delta U plus delta W. We know delta Q is 0, so 0 equals to delta U plus delta W. So delta U equals to minus of delta W. Okay, so this is kind of important. They might ask an assertion reason also this part. Okay, let's go. What is delta W equals to P delta P, right? So, okay, delta U equals to N CV root T. Okay, we will remove this one. Delta U equals to N CV root T. CV we know R by gamma minus 1. Delta U equals to anyways delta U is equals to delta W anyways. So delta U equals to N R gamma minus 1 T. And so we know PV equals to N RT. RT is given. Now we'll put it in terms of PV. So P final, V final minus P initial, V initial by gamma minus 1. But we forgot the fact that there was a minus sign. So that means the last final equation will be P initial, V initial minus P final, V final, gamma minus 1. So this is the final formula for the adiabatic. Okay. Okay. Okay, I'll be giving an important relation. PV gamma equals to constant. Okay. Second is okay, next I'll be giving you important relation. PV gamma equals to constant. TV gamma minus 1 is equal to constant. Last one is a bit confusing, so we will write the equation P equals to nRT. Okay. Now instead of V, we are going to put nRT P. Instead of V, we are going to put P equals to nRT, V equals to nRT by P. So that this equation I'm going to insert it over here equals to constant. This one, this is first equation, right? In this equation, I am going to put this. So it will be P to the power minus gamma, T gamma equals to constant. We know P equals to 1 minus gamma, T gamma equals to constant. So this is third one. This is first, this is second relation, this is third one. You know what is this? Gamma equals to Cp by Cv. Okay, this relation should be very aware. Okay. Okay, we have seen all the four processes. Let's do a graph and I'll tell you how to identify those processes. P, V. Okay, so let's keep this as A, B, C, D. Okay, let's actually, split the graph. First one, P, V. Let's take the A. This is the A part. You know, for how many values of V, P is there? There's only one P. That means here P is the constant one. If pressure is constant means the A will be isobaric. Okay. So this is the first thing we have done, one identification. A is isobaric. Next, let's go for B. one value. That means P will be, volume is constant because there's only one value of volume. Volume is constant. So B will be isochloric. Okay, A is isobaric, B is isochloric. Okay, now the conclusion comes with C and D. P, B. See, always remember in PV graph, adiabatic will be the most steepest one. Okay. In this, if you see, the most steepest one will be D. What is D? D is adiabatic. Okay, and C is the isothermal. Okay, there will be a lot of confusion between adiabatic and isothermal. So just remember this one, the most steeper one. The most steeper one will be adiabatic. The less steeper compared to adiabatic is isothermal. Okay. I want to tell you about the specific heat. Q equals to mc root E. You know, this is specific heat. So for isobaric, pressure is constant, we know, right? So C equals to Q mv root T. Okay, for isochloric, V is equals to constant, right? So C equals to Q by m root T. Now isothermal, temperature equals to constant. If temperature is constant, you are going to put T as 0. So Q equals Q by m into 0, which is infinity. 1 by 0 is infinity. Okay. And for adiabatic, delta Q equals to 0. That means C equals to Q by m root T 0. So C will be 0. So this is an important relation. Okay. Next. Okay, let's go with the bulk modulus. Bulk modulus equals to delta P by delta V by delta V by V. Now isobaric, P is constant. So B equals to 0 by delta V by V, 0. Isochloric, V equals to constant, that is B is 0, so B equals to delta P by 0, which is infinity. So this is also very important. This is bulk modulus. Bulk modulus is inversely proportional to the compressibility. Okay. Okay. Next, let's do one important graph. It was not given in textbook. Okay. P, V. You have to be aware of the arrows, where the arrows are going. Okay. So would you say this is expansion or compression? We know this volume is actually increasing. See the arrow. The volume is increasing. So it's an expansion. In this both graph, which is adiabatic and which is isothermal. And where the work done is so much. Work done in A is more or in B is more. First of all, in expansion, you should know the graph which is at the bottom is the most steepest one in expansion. So if more steep means it is adiabatic. And less steeper is isothermal. So now where is the work done more? Always remember, just just don't assume the work done by this adiabatic is more because it is more steeper. Here steeper does not play actually an important role in identifying the work done. What determines is the pressure, how much pressure it is holding. For example, okay, see in adiabatic actually what happens is that when you compress, no, the temperature cools down. If temperature cools down means the pressure drops so quickly in adiabatic, in expansion. So if more pressure quickly drops down means which has more work done? Isothermal. Because in adiabatic the pressure goes down so fast. As I said, don't just assume if a graph is more steeper, it has more work done. No. You have to see how much pressure is there. In adiabatic, during expansion time, the pressure drops so quickly down. So that means the work done in isothermal is greater than the work in adiabatic in expansion. Next, the pressure in isothermal is greater than the pressure in adiabatic. But which is more steep? Adiabatic, okay, in expansion. So always remember, in expansion, the curve at the bottom is the more steep one, okay? Next. Next, let's do compression. Just see the arrows, okay? Whether the volume is increasing or decreasing. Pressure, volume. So which is adiabatic and which is isothermal, and where the work done is more. In expansion we know the curve which is at the bottom is the most steeper one, but in compression the curve which is at the top is the more steeper one. More steeper means this is adiabatic, B is compression. A is adiabatic and B is isothermal. Right. Now, where is the work done more? In this both case, the work done at the adiabatic is greater than work done at the isothermal. Okay. Adiabatic is more steeper, but in this case, the adiabatic has lot more pressure. The pressure increases so much for adiabatic compared to isothermal, and we know the work done is about how much pressure is there. In this case, adiabatic pressure is more than isothermal, but the common thing in both expansion and compression is that the more adiabatic is the most steeper one in both the cases. So always remember, adiabatic slope equals to gamma into isothermal. Always adiabatic is more steeper, okay, but the work done in expansion of isothermal is more. In compression, adiabatic is more, okay. Okay, let's do some degrees of freedom, okay. Say gamma equals to Cp by Cv. We know this relation. But for monatomic gas, diatomic gas, triatomic gas, all these degrees of freedom are different with respect. It's like with respect to coordinate axis, y, x. Okay, if you're going to keep a molecule over here, it can orient in this direction, this direction, this direction. So that is what degrees of freedom is about. It is different for different gases, okay? It can be monatomic, diatomic and triatomic. For monatomic, degrees of freedom is 3 because there is only 3 translational. You have to know the formula Cp equals to F by 2 plus 1 into R, and Cv equals to F by 2R. Okay? Now we know degree of freedom is 3. Insert the 3. 3 by 2 plus 1 into R is 5 by 2 R. CV equals to 3 by 2 R. Gamma equals to CP by CV. 5 by 2 R in 5. 3 by 2 R. 5 by 3. Okay. For monatomic gas, gamma equals to 5 by 3. Okay. Next, let's go to diatomic. For diatomic, the degrees of freedom is 5 because there is 3 translational and 2 rotational. So that means gamma equals to Cp by Cv. Cp is F by 2 plus 1 R. Cv is F by 2 R. So 7 by 2 R. So 5 by 2 R. 5 by 2 R into 2 by 5. Cancel. 7 by 5. This is for diatomic. You have to know this one. Next, this is at the room temperature scenario. This is for room temperature. If it is high temperature, same thing only. F equals to 5 plus you have to add it to. This is for vibrational. When you heat, right, it vibrates. So we're going to add plus 2. F equals to 7. This is for high temperature. Cp equals to 9 by 2 R. Cv equals to 7 by 2 R. Gamma equals to 9 by 7. This is for high temperature. This is for room temperature. Okay. Let's go for triatomic. In triatomic, there can be 2 scenarios. One is non-linear, other is linear. In non-linear, you can take example of H2O. For linear, you can take example of CO2. Right? We know the degrees of freedom is 6. 3 is translational, 3 is rotational. So total 6. Cp equals to 6 by 2 plus 1, 4 R. Cv is 3R. Cp by Cv 4 by 3. Okay. For linear, it is degrees of freedom is 5. That is 3 rotational. Okay, for linear it is degree of freedom is 5. 3 translational, 2 rotational. So Cp equals to 3 by 2 plus 1, which is 5 by 2 R. Cv is 3 by 2 R. Gamma equals to Cp by Cv equals to 5 by 3. And this is for non-linear. This is for linear, okay? Next, in linear, what if it's a high temperature? This is for room temperature. For high temperature, we have to add 2 more for vibrational. So F equals to 7 because 2 vibrational. Cp equals to 7 by 2 plus 1, 9 by 2 R. Cv is 7 by 2 R. So gamma equals to 9 by 7 for high temperature. Okay. So this for non-linear, linear, high temperature. Okay. Okay guys, okay, that's all for today. So we have seen some main concepts like the processes and the work done, as well as the graph and degrees of freedom. This part is the most confusing part, but we have made it easy over here. So you have to practice more questions on this, and next video let's do some graphs and Carnot engine.